In video 4, we're going to use our trig to solve the right triangle. So what that means when we solve a right triangle is that we need to find all the missing sides and all the missing angles in the triangle. Sometimes we could use Pythagorean theorem, sometimes we could use our inverse of our trig, or sometimes we could just use the regular trig ratios, and it just depends on how it's set up and which one we want to find first. Again, make sure that your calculator is set into degree mode. Otherwise, when you type it in the calculator, you'll get a really odd looking number that does not make sense for our answers. All right, so for number 1, if we need to solve this triangle and it has a 40-degree angle and a 20-inch hypotenuse. So it's up to you of which angle you want to put where, but I'm going to put my 40 degrees right here, and my 20 inches for the hypotenuse has to go right there. Next, we want to label it just like we did before. So my BC over here is my opposite. I have hypotenuse already, and my adjacent is going to be right there. I'm going to label all the different sides that are missing in the angles as my X, Y, and Z. So my angle I'm going to put as my X, my side BC is Y, and then my side AC is my Z. And it really doesn't make a difference which one you label as what, as long as you label them as something to make it easier to follow your work. If we want to find, let's see, if we want to find our X first, an X is an angle, and we already have 2 angles in our triangle, and we know that if we add up all 3 angles together, that should equal 180 degrees. So if we go ahead and do that, that gives us 130 plus X equals 180. When I subtract my 130 over, we end up with 50 degrees. So my angle B is going to be 50 degrees. Now you could put that in your picture, or you can just leave it out and just use it based off of the 40 again. Otherwise you have other options that you can use. Next, if I want to solve for my, let's do Y, I have to use the Y, and I need to use the number that is given to me in the side of my triangle. So we have opposite and hypotenuse. And this is for my Y. And opposite and hypotenuse is sine. So sine of my angle would be my 40. Opposite is my Y. My hypotenuse then is 20. I need to put it over 1 so I can cross multiply. And I end up with sine of 40 times my 20 equals Y. I can type all this in the calculator at the same time. And when I do that, I get 12.856. And it doesn't say how we're going to round it, but we're just going to round it to the nearest 10th place again like we did before. So that means that my Y is 12.9 because it's a 5 right after it, so I got to bump it up. And side Y is my BC. So let's put it back as BC, and that equals 12.9. Lastly, we want to find what our Z is going to be. Now, one thing you notice is that we already have 2 sides in our right triangle, and we could use Pythagorean theorem to solve for my Z. But because my one side of BC is not a whole number, it's a decimal, that means since we rounded it, my Z might be slightly off as well. So I'm not going to use Pythagorean theorem, I'm just going to work back with what we had before. So I need to use my Z, and I have to use the 20 because that was given to me. So adjacent and hypotenuse is cosine. So we have to use cosine of our angle, so of our 40 again. Adjacent over hypotenuse, so my Z over 20. We put it over 1 and cross multiply, so I get 20 times cosine of 40. Remember that whole thing can be typed in the calculator, equals 1 times Z, so I just have a Z on that side. My Z, once I type 20 times the cosine of 40 in the calculator, I get 15.320888. We got to stop it after the 3. So because it's a 2, it's going to stay a 3. So my Z is going to stay 15.3. And my Z is really side AC. So AC is equal to 15.3. Number 2, when we solve our triangle, if you notice, we start with different pieces. This one we have 2 sides to the triangle, and we need to find what the angles are, plus 1 more side in the triangle. Again, we want to start out with just labeling our different pieces. So if we label the 2 inside angles as X and Y, and then my outside side will be a Z. If I want to start with one of the angles, so if I want to start with my angle X, I need to base all my sides off of that. So this is going to be opposite. We have hypotenuse, and this is adjacent. And with my x, I have to use the 2.7, and I'm going to have to use the 3.1 because my x is a variable, so I need two side lengths. So opposite and hypotenuse gives me sine. So the sine of x is equal to opposite over hypotenuse. So 2.7 over 3.1. To find the angle, remember, we have to use the inverse functions. So the inverse of sine of 2.7 over 3.1. And when we type that in the calculator, this gives me 60.57129. We've got to stop it after the 5, so that makes it a 60.6 degrees. So this is my angle A, is 60.6 degrees. Now to make it a little bit easier, once I have one of the angles, it's real easy to find the other angle. So to find my y variable, or my angle B, I know that all three angles have to add up to be equal to 180 degrees. So I already have the 90. I know my y is just going to stay my y, but now my angle A is my 60.6 equals 180. So when we solve this for the y, we end up with the other angle is going to be 29.4 degrees. That would be angle B is equal to 29.4 degrees. For the last side, for my z, I need to use one of the other two sides. So it doesn't really make a difference if I use 3.1 or 2.7. So I'm going to use opposite this time. So if I've got opposite and adjacent, that means I've got tangent that we are going to be using. So tangent of my x, and we already know the x is 60.6 degrees, equals our opposite over adjacent. So when we cross multiply, we end up with z times the tangent of 60.6 equals 2.7, and I need to divide that. So 2.7 divided by the tangent of 60.6. And when we do that, we get 1.52137. We got to stop it after that 5, so we get 1.5. And that would be for my z, which is AC. Now that I've done two whole questions, I want you to go through and find some other pieces. First, let's go ahead and label the different missing pieces. So we have x, y, and z, just so we have the same variables. So I want you to first solve for the x. What you notice for your x is that it's inside your triangle, and we already have two angles. So you should have taken 56 plus x plus 90 equals to 180, which means that angle x ends up being a 34 degrees. So my angle F is 34 degrees. Next, for our y, we're going to base everything off of the 56 we were given. So this would be opposite and our hypotenuse and adjacent. So if we want to find what the y is next, I want you to decide which trig ratio we need to use if we have to use our y and the 26 meters. You should have chosen to do the tangent of our angle, so 56 equals our opposite over adjacent. Now for the solving part of it, I want you to go through and I want you to solve for y. You should have cross multiplied, so we get a y equals 26 times the tangent of 56, and then when we type that all in the calculator, we are going to get 38.546585. When we stop it after the 5, it's a 4, so it's going to stay 38.5. And this is meters, since that's the side, and this is my y, so it will be side EF, will be the length of that side. For the remaining side, we need to find our z. So if I want to use my z, and let's just use our 26 we started with, and that gives us adjacent and hypotenuse. We're on to cosine of 56 equals adjacent over the hypotenuse, so our z. And now I want you to solve this one for your z. When you cross multiply, you should be getting cosine of 56 times z equals 26. So to solve for z, we need to take 26 divided by the cosine of 56, which gives us 46.49558. When we stop it after the 9, that means that it bumps it up to a 50, so we have 46.50, and this would be our side z, so that would be df. I'm going to try squeezing it in there. For the very last question, we have a word problem, but the picture's already drawn for us to make it a little bit easier, and we have two separate questions. We want to figure out what the maximum height of the ramp is going to be, and we want to find the distance along the ground that the ramp would cover. So I'm going to label that as my D. So I don't need the other angles. All I need are those two sides. And we got to base it off of this 3.5 degrees. So my H is my opposite. D for my distance would be adjacent. And 30 is my hypotenuse. If we want to solve for the H first, we have opposite, and then we're going to have to use the hypotenuse because that's where our number is located. And which trig function uses opposite and hypotenuse? That would be the sine of the angles. So 3.5 equals our opposite. So h over hypotenuse would be 30. To cross multiply, we're going to be taking 1 times h, so we get h. And then 30 times the sine of 3.5. So type all of that in your calculator, and our height is going to be 1.831456. Again, we want to round it to the nearest tenth of a foot, so that's after the 8. So we look at the 3, and it's not 5 or bigger, so it's going to stay 1.8 feet. Next, when we want to find the D's, the distance on the ground that the ramp covers, we need to use our 30 feet again, and then our D. We've got adjacent and hypotenuse, and the cosine is the one that uses adjacent and hypotenuse. So cosine of our angle, 3.5, equals your adjacent over hypotenuse, so D over 30. Put it over 1, cross multiply, so 1 times D is D. 30 times the cosine of 3.5, we're just going to leave that way. But we can type this into the calculator, so 30 times the cosine of 3.5, we get 29.94404. Again, we want to round to the nearest tenth, so we stop it after the 9, and the number after the 9 is a 4, so it's going to stay at 29.9. And this would be feet, and this is the distance along the ground.